Hi folks, welcome to day 8. Today we're going to be learning how to do some simple factoring. So yesterday you had an opportunity to check out what it looked like and how to solve a polynomial once it's already in factored form. And today you're going to learn how to do some simple factoring. And today we're going to be learning how to factor out monomials from a polynomial. Remember, a monomial is just one term. So today we're going to learn how to factor out one term from a polynomial. All right, so what we're going to be doing is we're going to be learning today about greatest common factors. So you've probably learned about this in elementary school and middle school. All right, so if we have two numbers, like let's say we have 12 and maybe we have 18. If we're trying to find the greatest common factor between the two, we're going to start by writing out their factors. Remember, factors is just a fancy pants name for, hey, things that multiply together. So, for example, 12 has factors of 1 times 12, because 1 times 12 is 12. Right? It also has 2 times 6, because 2 times 6 is 12. And it has 3 times 4, because 3 times 4 is 12. Now, technically, it also has 4 times 3, but we don't include that because 4 times 3 is the exact same thing as 3 times 4. So those are the three factor sets of 12. So we have 1 and 12, 2 and 6, and 3 and 4. We're going to do the same thing for 18. All right, 18 has factors of 1 times 18. Right, it also has 2 times 9, 3 times 6, and 4 doesn't go into 18, so we don't include it. It has a decimal, so we're not going to include that. 5 also goes into 18, but it has a decimal, so we don't include that. We only include factors that have whole numbers. All right, so the next one we would write down is 6, because 6 goes into 18. But 6 goes into 18 3 times, so its counterpart would be 3. We already have that listed, so there's no need to list it again. All right, so that means we have factors of 18 being 1 and 18, 2 and 9, and 3 and 6. So this thing that we're going to be talking about, we're going to be applying to algebra, is something called the greatest common factor. So the greatest common factor, all that it says is the biggest, so the greatest, meaning biggest, and then common factor, so the biggest number that goes in to both numbers. So if we're looking at 12 and 18, we can see everything, like any two numbers will always have we'll always have a common factor of 1. We're trying to find numbers bigger than 1. All right, so you see that 1 goes into both 12 and 18. 2 also goes into 12 and 18. Keep going up till we find our biggest number, so 3 goes into 12 and 18. Now, after 3, we'd have 4, but 4's only in 12. It's not also in 18. All right, so with that one, since it's not in 18, well, I'm going to go ahead and I'm going to erase it so that way I don't get myself confused. I'm only going to highlight things that are in both 12 and 18. All right, so let's see. After 4, we go to 5. Neither of them have 5. So then we go up to 6. Oh, look, we can see that 12 has a factor of 6, and 18 also has a factor of 6. And we can go on, keep going up, 7, 8, 9. You can see that 9 is a factor of 18, but not of 12. Then we can see 12 is a factor of 12, but not of 18. So our biggest number that goes into both 12 and 18 is 6. All right, so that's what we call our greatest common factor. All right, now what we're going to be doing when we're factoring polynomials, right, we're factoring things that have x's in them. The first thing that we're going to do is find this greatest common factor, right? But we're going to find that of the coefficients. And the greatest common factor of the variables is always the smallest power of x. So what we're going to be doing today is we're going to be finding the greatest common factor of the coefficients and then finding the smallest power of x. Now, if you were using different variables other than x, then, you know, it would be the smallest variable, but in my examples, I'm just going to use x because it's our most common variable. All right. So let's go ahead and try an example because I think that this is easiest to see with an example. So if we have something like 2x squared minus 4x. What we're going to do is we're trying to find the greatest common factor overall, which means we're going to look for the greatest common factor between 2 and 4, and then include the greatest common factor of the variables, which is just the smallest power of x. So you're going to want to start by writing out the factors of 2 and 4. I usually do this in a factor tree because it just makes more sense to me, but you don't have to. All right. So 2 is a prime number, so that means that its only factors is 1 in itself. So you have 1 times 2, and then for 4, you have 1 times 4, and 2 times 2. So the biggest number that's the same between them is 2. That's the biggest factor. So we're going to have to factor out a 2. But we're also going to include our smallest power of x. And our smallest power of x in this case is just x. So that means we're factoring out a 2x from our starting term, 2x squared minus 4x. So in order to factor out something, what you're going to do is you're going to start by writing the greatest common factor. In our case, remember, that's that 2x. So we start by writing our greatest common factor out front. Then we draw our parentheses. We write our original term inside those parentheses, so 2x squared minus 4x, but then we're also going to be dividing that term by our factor. All right? And the reason why we have to do that is because that's what it means to factor out something, is you're taking it out of the term, so you have to divide it out of the terms. All right? So when we do that, we're left with a 2x out front, and then we have 2x squared divided by 2x. So remember, anytime that you are going through and dividing, if you are dividing a term that has variables in it, remember the numbers divide, but the exponents, right, the exponent piece, the exponents subtract, all right? So remember to subtract these. So we have 2 divided by 2 gets us 1. You don't have to put the 1 there. I'm going to put it there so that way I remember that there's a coefficient. And then we do x squared divided by x. X squared divided by x is, like I said, you have to subtract those exponents. I'm going to do that in like this fuchsia color. So we have x squared minus, oops, not minus x. We have x squared divided by x, which gives us an x squared minus 1, so x to the 2 minus 1, because remember your exponents subtract when you're dividing. If you don't remember that, check out chapter 5 in your textbook. So you have x to the 2 minus 1. 2 minus 1 is just 1, so we're left with x to the 1, or just x. All right, and the reason why x to the 1, we just call it x because 1 is the most common exponent, so we just, it's an implied x. Just like we don't normally write our 1 as our coefficient, it's implied. All right, so then we have 4x divided by 2x. And don't forget to carry over whatever that sign was up above. Unless you're factoring out like a negative number, the sign stays the same, all right? So we have 4x divided by 2x. So that means we're going to divide our coefficients. 4 divided by 2. 4 divided by 2 is just 2. And then we have x divided by x, which is just 1. Or we get, if you want to do the subtraction way, that gives us x to the 1 minus 1. 1 minus 1 is 0. That gives us x to the 0. Anything to the 0th power is just 1. All right, so our final answer is this 2x times x minus 2, or 1x minus 2 if you want to include that 1. That's our fully factored form. Now, my recommendation is when you're trying these out for the first time, if you don't feel confident in your ability to factor even basic numbers, check your answer. Here's how you're going to check your answer. All you got to do is distribute that back in. So we have 2x times 1x. 2 times 1 is 2. X times x gets me an x squared. All right. Distributing in my 2x to my negative 2, I get negative 2 times 2, which is 4. And then the x comes along for the ride, or x times 1 is x. So you're left with 2x squared minus 4x. That's exactly what we started with, so that's good. So you can always check your answer by distributing in your factor. If you don't get what you started with, you did something wrong. All right, let's go ahead and do one more example because I don't want to keep my video too long. If we had something like, maybe we had say we have a 12x to the 4th minus 4. All right. So just like with our last example, we're going to start by listing out our factors, all right, of our coefficients. So my factors of 12 are 1 and 12, 2, and 6. And if you don't remember how to find factors, I think it's easiest to have a calculator or your phone or whatever next to you, and just do, you always know that you start with 1. If it's an even number, the next factor will be 2. And then just go up and do maybe 3. Maybe I don't know my factors of 12. And I would do 12, because my next one is 3, do 12 divided by 3. If it was a decimal, then we wouldn't include it. But in our case, it's not a decimal, because 3 times 4 is 12. So then we'll include it then. All right. But yeah, so you don't include factors that aren't whole numbers. All right. And then our factors of 4, we have 1 and 4 and 2 and 2. All right, so our biggest number, the greatest common factor, the biggest number between them is going to be 4, because 4 goes into 12 and 4 goes into 4. All right, so we found our greatest common factor of the coefficients, but then I told you you have to also include the smallest power of x. Now, in this example, our smallest power of x is right here. And you can see that I am circling nothing. There are going to be some of you that say, okay, well, then I'm going to pull out a 4, and I'm going to pull out nothing, which is 0. You're going to say, oh, so then it's 0. No, that's not how that works. All right, there's no smallest power of x, so we only need to pull out the greatest common factor of the coefficients. What that means is that there's not a greatest common factor of variables in there. All right, there's no smallest power of x that you can pull out because not all of the terms have x. If not all of the terms have x, you can't pull out an x. All right, so I'm going to go ahead, write my 4. I'm going to do it in green, actually. I'm going to write my 4 out in front. All right, and then I'm going to go through and divide. I'm going to divide my original expression by 4 because that's my greatest common factor. So we have 12x to the 4th divided by 4. All right, 12 divided by 4 is 3, and the x to the 4th just comes along for the ride. All right. Going to do the same thing with that 4. We do 4 divided by 4. 4 divided by 4 is just 1, so you're left with just 1. So your final answer for this one would be 4 times the quantity, 3x to the 4th minus 1. All right, so you don't need to pull out a variable if it's not in the greatest common factor. All right, so if there's no smallest power of x, then you don't pull out an x. I do go through several more examples in your in my written notes, so you're welcome to read through these. And keep in mind, if there were more than 2 terms, right? So I'm going to give you one of your mini assignment problems today is going to be something with 3 terms. All right, you do the exact same thing that we did up in this example here, with the only exception is instead of dividing by 2 terms like we did, or dividing each term by our greatest common factor, you're still going to divide each term by the greatest common factor, but the difference is you'll divide your first term by the greatest common factor, your second term by the greatest common factor, and then whatever your third term was, right? So if we had I'm going to do it in black so you know that it's not part of this problem, but if there was a plus 3 here, or maybe there was a plus 3x squared, or 3x to the 4th, because then it's not part of that, not part of the first term, our leading term. All right, so if we had something like 3x to the 4th here, then we would also have 3x to the 4th divided by our 2x, because that was our greatest common factor. Obviously, that would have changed the entire problem in terms of what the greatest common factor was, but that's okay. If we change this to an 8, then we're good. So that's what we'll do. But yeah, so if there were 3 terms, the only difference is then you have 3 terms to divide instead of just the 2. All right, so don't be constrained by the fact that this has 2 and my other example had 2. It's okay that if yours don't have 2. All right, you follow the exact same steps as you would with a normal one with only 2. All right, so go ahead and give that assignment a try. Let me know if you have any questions. Email me. Tune into my office hours, which will be tomorrow. All right, I'm going to have office hours tomorrow at 10. I think it's at 10. Double check my announcement for that. But yeah, other than that, have a great rest of your day.